Okay, we're going to talk about solving multi-step inequalities. And again, we've done all this in the form of an equation. Like I said, the only issue here is there are a couple of things we're going to want to watch out for and make sure that we're aware of. Okay? So the whole point here, we're going to talk about using multiplication and division to solve inequalities. And again, how to model using multi-step inequalities and solve those guys as well. And you see the standards we're going to hit. Okay? So, again, probably, I think even some review. I'm sure you guys have seen this before. If you want to solve this first out, number one, x over 3 is less than negative 2. Okay? We want to isolate x. You need to isolate x. What are you going to do to isolate x here? Yeah, multiply both sides by 3. Right now, we're dividing by 3. We're going to multiply both sides by 3. Just say. Okay, multiply both sides by 3. X is going to be less than negative 6, right? And then we're ready to graph. Negative 6 is here. Open or close circle? Open. Left or right? Yeah, we want to go left. X is less than. X is less than. Okay. Again, quick, I just want to mention this. Once you have your inequality solved and your graph created, another reason why it's nice to have 0 in on this graph is that can be your quick check. Plug 0 in and see if 0 is supposed to be a solution or not, right? Put 0 in for x. Is 0 less than negative 6? No. So it shouldn't be part of the shading, right? So it makes sense that the shading is going the other way. It should not include 0. Hang on to that idea. I'm going to start talking about graphing inequalities in 2 variables, which we'll get to much later. We'll revisit this whole 0 thing. Okay? All right, number 2, you want to isolate x. Simple enough. What are we going to do? Yeah, that's it. Divide by 4. Divide by 4. Okay? When we do x is greater than or equal to 5. Okay? So we come down here and put 0. To the right, we put 5. Open or close circle? Closed, because 5 is the solution. 5 does equal 5. And then we're going left or right. Should be going to the right. If you're not sure, plug 0 in. Is 0 greater than 5? Is 0 greater than 5? No. So 0 should not be shaded in. Okay? Quick check. So, no big deal. Just like we were doing before with solving equations, just going to undo division by multiplication and multiplication by division. There's, like I said, I keep saying there's one little wrinkle. And that one little wrinkle is if you multiply or divide by a negative number. Okay? If you don't remember, the trick here is when you multiply or divide by a negative number, you have to reverse the inequality. Why? Why do you have to do that? Okay? Right now, since we're on this, the bandwagon of checking to see if 0 is a solution, is 0 a current solution to that inequality there? Right? And all we have to do to check is to plug 0 in. 0 times negative 6 is 0. Is 0 greater than or equal to 24? No. It's not a solution. Now watch what happens. If I divide both sides by negative 6, and I don't reverse the inequality, I get x is greater than negative 4. Now plug in 0. Remember that what we're doing when we're isolating a variable. We talked about this when we were solving out equations, and even here again in inequalities. The idea is we're creating an equivalent inequality that means the same thing, just looks different, right? Has the same solutions, just looks different. Well, what if we check 0 again? If I plug 0 in here, okay, is 0 greater than or equal to negative 4? Yeah. Now, all of a sudden, 0 is a solution. So these two are not equivalent inequalities. However, if you do what you're supposed to do and reverse the inequality, then 0 becomes not a solution like it was originally. Hence the reason why we have to reverse the inequality. Negatives kind of change the game that way. Okay? Moral of the story is, if you ever divide or multiply both sides of the inequality by a negative, you've got to flip the inequality sign. Okay? That's it. That's the only thing you got to worry about. I mean, it's a big thing because there's going to be a tendency to sort of forget that. But in the end, you can always check by plugging in 0 to make sure you have equivalent inequalities. Okay? All right. Let's do a couple here. Okay, number 3, negative x over 4 is less than negative 1. Is what you should see. And number 4, negative 9y is less than or equal to 63. Take a couple seconds and try those, and we'll come back together and see what you should get. Okay, we're going to isolate the x in number 3. We have to do what then? We're going to have to multiply by... Right, negative 4. Those will divide out, leave us with just x. Negative 1 times negative 4 is 4. And so x is going to be greater than 4. Yes, we've got to flip it. Okay? So we put 0 here, put a 4 there. Open or close circle? Open. Left or right?
Right.
Correct. If you're not sure, plug in 0 and make sure. 0 is greater than 4? No, I don't think so. Okay, so you're shading in the right solutions. Number 4. Same deal, right? If you want to isolate y, you have to divide by negative 9. And so y is going to be, we're dividing by a negative, greater than or equal to negative 7. Okay. 0 here. Oh, wrong side. Negative 7 here. Open or closed? Closed. Left or right? Right. Y is greater than. So let's go to the right. Okay. Plug in 0. 0 is greater than negative 7? Sure it is. So 0 should be part of your shading. Okay. All right. Take a look at a quick word problem together. What happened? Sorry. Here we go. Story problem. You walk dogs in your neighborhood after school. You earn $4.50 per dog. How many dogs do you need to walk to earn at least $75? And let D be the number of dogs. So we've already defined the variable for you. You don't have to worry about doing that. Right? You want to earn at least $75. Are you okay earning more than that?
Yes.
Sure you are. I hope so. Right?
That means you have to work extra.
So that means that whatever you earn needs to be greater than or equal to $75. How do you figure out how much you earn? Right? Well, what are you going to write down to represent how much you will earn? It's $4.50 per dog. Per is that word again that we're going to use to represent multiplication. Let multiplication represent it. So 4.5D is greater than or equal to 75. 4.50 if you want, since it's money. Okay, and then pretty simple here. We're going to divide by 4.5. So D is, do we flip the inequality sign? We're dividing. It's going to be D is less than or greater than? Right. Keep it the same. That's right. We're dividing by a positive, so we keep it the same. Just a quick check to make sure you're paying attention. So it's about 16.7. So how many dogs do you need to walk to earn at least $75? Right. You'll need to walk at least, I didn't say that in here, at least 17 dogs. Okay? Any major issues or questions there? All right. Okay. We need an inequality to help us out here for number 6, and we've already defined the variable for you. We're going to let C be the number of cases. Okay? Hey, here's the inequality that you want. You can't spend more than $50. So however much you do spend has got to be less than or equal to 50. And the way you calculate how much you spent is to take the $10.68 and multiply it by the number of cases that you buy. Good. Divide both sides by $10.68. And C is less than or equal to? What'd you guys get? 4.7? So what are the possible numbers of cases the club can buy? The club can buy
4, because you can't have several.
at most, right, 4 cases. At most 4 cases. You can't buy any more than that. But you can buy less than that, right? So at most 4 cases. Okay. Questions? Okay. All right, then let's solve these guys out. What'd you come up with? Brooke, you and your partner. 9 plus 4t is greater than 21. Yeah, walk us through it.
We did minus 9.
Okay.
And then we got 14 is greater than 12.
Okay.
And we divided by 4.
Okay.
And that t is greater than 3.
Okay. Good. And that's it. And that's it. Right? Number 8. Logan, number 8. You and your partner. Okay. All right, go ahead. Let's walk through this.
Okay, so I added 7 to both sides, and I got to 24.
Okay.
You divide -6 by 24, and then you get A is greater than or equal to -4. Wait, no. -4.
Right. Flip the inequality sign. We divide by -6. Good. Perfect. Flip the inequality sign. Okay. Nice. Number 9. Alyssa, what did you guys come up with? Number 9. What is it? V is greater than 3. Okay. Is that it? So subtract 5, subtract 5. So negative 3v is greater than negative 9, right? Then we got to divide by negative 3. And so v is less than. Make sure you flip that sign because you divide by that negative. Okay?
Me too.
Don't forget to flip that sign. So it should be less than. Okay? So be careful there. All right, and then number 10. And then number 10. We should end up with, what, Zach? What did you guys come up with? And walk us through it. Good. Didn't flip the sign? Didn't flip the inequality sign? Okay. Divided by a positive, right? We didn't need to there. So you should end up with that guy right there. Good? All right? All right. And some confusion on number 11. So you've got 42 feet of fence. That's it. That's all you can use, right? And you're going to put up a fence around your garden, this community garden. And you needed the picture there. The garden's 12 feet wide. What are the possible lengths of your garden? You don't have to use all 42 feet. Okay? But since we're going to put up a fence around the garden, that's perimeter, right? And so we have the perimeter formula, and we know that we have 42 feet of fence at most. So whatever we use has to be less than or equal to 42 feet. And the perimeter formula will tell us how much we're going to use, right? And so we'll just take the 2L plus 2W, and that has to be less than or equal to 42. Okay, now the length we don't know. You can leave it as L if you want. The width was 12. And so some of you guys are on the right track here. So that's the inequality that you want to go through and solve. And I'll bring it back over here. So subtract 24. That needs to be turned off very, very fast. Okay, and so we run out of room again. L is less than or equal to 9. Okay? And let you do some more work together, and we'll come back and see what you got. Okay? Number 12, you want to make a rectangular banner that is 18 feet long. You have no more than 48 feet of trim for the outside edges of the banner. What are the possible widths of the banner? Okay? Again, if you're going to put an edge or a border around the banner, okay? We're talking about perimeter, right? Okay, so, but we have no more than 48 feet of trim, so it's a lot like this fence problem last. We're going to put trim around this thing, but we know we can't use any more than 48 feet. So however much we use has to be less than or equal to 48 feet. Now, how do we figure out how much we're going to use? Well, it's a rectangular banner, so if this side is 18 feet, how long is this side? Sure. Don't know the width. So, but we know there's two of them, right? And so for that banner, Center Grove loves math. Of course you do. Right? Perimeter, add up all the sides. If you're gonna create an edge, if you're gonna create a trim around this banner, we just add up all the sides, right? Or you can use that 2 times the length plus 2 times the width that we just used in the last problem. The length is 18. The width is just W. And then we're off and running and solving this inequality. Okay, subtract 36. And then divide by 2, and the width has to be less than or equal to 12 feet. Okay, so what are the possible widths of the banner? To answer that question, we're going to write out a sentence. The width can be no more than 12 feet. Okay, you want to make sure that we're writing out a nice complete sentence. All right? So kind of the same as the last guy. All right. I'll show you one here, and then I'll turn you guys loose. Number 13, we're going to add some more steps, right? We've got 2 steps. Now we're going to add as many steps as it takes. Right? We're going to follow our simplifying rules using PEMDAS if we need to, and then our rules for isolating variables. Number 13, 3 times t plus 1 minus 4t is greater than or equal to negative 5. First thing you want to do, it's almost instinct, isn't it? Yep, that's it. That's the word, distribute. Yeah, that's right. Distribute the 3. So 3 times t is 3t. 3 times 1 is 3. Okay. Combine those like terms. Right? Combine like terms. And when we combine like terms, we just add the 2 guys together. So 3t plus negative 4t is negative t. Now we got to subtract 3. Then divide by negative 1. Because there's a negative on that t, we've got to divide by negative 1. And so t ends up being, divide by a negative, flip the inequality. T is less than or equal to 8. So be careful. Watch yourself. Okay. All right. Any major issues or questions there, though? All right. Finish these guys. Right. But if you flip the whole thing, you're supposed to flip your inequality sign, too. So I'd be careful about doing that as well. So what you should end up with here is m is less than or equal to negative 3, or negative 3 is greater than or equal to m. Okay? Good. Questions? Okay? All right. Let's go ahead and skip down to 17 and 18. I think that's why these were rearranged to begin with. Because we want to see what happens here. So, Christian, how about it? What are we going to do first? All right, so we get 10 minus 8a. Great, now what?
Put no solution. Because if you add 8a to both sides, you get 0.
Okay, right. If we add 8a to both sides, this is going to add to 0, this is going to add to 0, we get 10 is greater than or equal to 10. Is that true?
Yeah.
Is it always going to be true? No matter what we plug in for a, right? So not no solution, it's actually the exact opposite, which is right. Infinitely many. Okay? Compared to number 18, right? Where you combine like terms. You get 6m minus 5 is greater than. Combine like terms here, you get 6m plus 7. Now when you subtract the 6m's, they're going to add to 0. You get negative 5 is greater than 7. Is negative 5 greater than 7? No. Is negative 5 ever going to be greater than 7? No. So no matter what you plug in for m, it's not going to be a solution. So this is no solution. Okay? And to carry this one step further, see if I can do this. To carry this one step further, infinitely many solutions. How would you graph that? Put 0 here, 1 here, -1 here. Do you have an open circle or closed circle anywhere? What's that? Yeah, but how do you graph it? Because we've been graphing the solutions to the inequalities, right? Yeah. You just shade the whole number line in, right? Everything on that real number line is going to be a solution. So you shade everything. If it's no solution, your graph would look like, here's the number line. Your graph would look like that. Just that. You don't shade anything. Right? All right. Good. So there's 17, 18, 15, 16. Really quick. Get you through there, right? So we're going to subtract 3 in from both sides. Or just do this here. Not that they were both done. There's 16. Check 16. And there's 15, right? So you should end up with n is greater than 3 for 15, and b is greater than 3 on 16, okay? That's it. Any major issues or questions? Got a pretty good handle on it? Okay, homework's posted in Canvas. You got some time, so go ahead and get that out and start working on that.